Hello, my name is Jesse Baker and I'm an applications engineer supporting position sensing products. In this video, I will discuss how to use the TI Magnetic Sense Simulator, TIMS, to simulate the magnetic field at a single point with a static magnet. Magnetic simulations are often completed to determine the behavior of a changing magnetic field as a result of magnet motion. However, at times it may be beneficial to simulate the magnetic field at a single point with a static magnet. This function is available in TI Magnetic Sense Simulator to quickly determine if the field produced by a magnetic structure is strong enough or in the correct direction to be useful in a given application. Note that sensor selection is not applicable for static position simulations. When the static function is selected in TIMS, only the magnet origin position is available under the magnet motion dropdown. The first is the position. This defines the location of the magnet center. Using the x-axis, y-axis, and z-axis inputs, it is possible to place the magnet anywhere in 3D space. The second row is the angle that determines the orientation of the magnet. It may be necessary to rotate the magnet about the x, y, or z axes to match the desired alignment to the simulation point. All rotations are carried out in XYZ order. Finally, note that there are no settings available under the Sim Settings tab, as this function does not involve any motion. To demonstrate, I'll walk through an example simulation setup using the tool. In this case, I will select static position for the function type and will use an axial cylinder magnet for this example. Now we are ready to start configuring the simulation. I will leave the default magnetic material selected as a neodymium type N35 magnet and will also leave the default geometry as a cylinder with a 3 mm outer diameter and 6 mm height. I can place the magnet such that the bottom of the magnet is at the origin by setting the x and y axis position to 0 mm and the z axis position to 3 mm. I will set the sensor position at 0 mm in the x-axis with a 1.5 mm offset in the y-axis and -5 mm offset in the z-axis to simulate the magnetic field at a point 5 mm from the bottom of the magnet and aligned with the outer edge of the magnet. When the simulation completes, we can see the overall magnitude and Bx, By, and Bz magnetic flux densities at the point we have chosen graphed on the plot. In this case, the Bz vector is the strongest at a value of 17.251 millitesla. Although static positions only generate magnetic flux densities for a single point on the output graph, the parametric sweep function in TIMS can be used to generate results for a set of points. For example, consider the case where, for my previous simulation, I want to have an idea of the magnetic flux densities at sensor Z positions of -7 mm and -10 mm as well. To do so, I can click on the Parametric Sweep tab and perform an individual sweep of the sensor position Z parameter. I know the specific values I want to simulate, so I will perform a discrete sweep, input the desired values, -10 mm, -7 mm, and -5 mm, and click Simulate. If I navigate to the BZ tab, I can see that the Z component of the magnetic field is 8.633 millitesla at -7 mm and 3.842 millitesla at -10 mm. Several other parameters are available for these sweeps, and up to 3 parameters can be swept at a time using a combinational sweep. That shows how to simulate the magnetic field at a single point with a static magnet, and how to use a parametric sweep to gather a set of points. To learn more about TIMS and these types of simulations, please see the relevant collateral linked here. To get started on your own static position simulation, please visit www.ti.com/TIMS.